All right, we are going to be doing adding and subtracting in scientific notation. Adding and subtracting scientific notation. All right. This particular lesson is a little bit different than the other ones, so we really got to pay very close attention to what's going on. This area has been challenging for a few students. You'll see why, mainly because the rules change a little bit. And there's something that's added that you hadn't seen before. So let's look at it. I'm going to give you a simple one. It looks like this. Let's say we have 2 times 10 to the third plus 3 times 10 to the second. All right. Now, I want to go the regular way. When all else fails, just work it out the way you see it. I don't want you to make it complicated or anything. Watch what happens if we work it out the regular way, right? This would be 2 times 1,000, all right? And this side would be 3 times 100, okay? All right. Now, you already know what those answers are going to be. This side here would be 2,000. And this side here would be 300. And you add up 2,000 and 300 and you get 2,300. Done. You're right. That's it. All right. Now, I have to show you that there is another method that you might consider a little bit more cumbersome or complicated. Now, you might be right in some situations, but take it from me, you're going to need to know this other method. I'm going to use the exact same problem. All right, so let's look at it again. It says 2 times 10 to the third plus 3 times 10 to the second. All right, what I want you to do this time is understand that I want to combine these two without working out this side and then this side. All right, so this is what I want you to do. In order for me to actually add these two, my exponents must match. See my exponents? They don't match. So I cannot add these two without using this method first by converting these numbers and changing them to standard numbers. I don't want to change this to 2,000. I don't want to change that to 300. All right, I want to leave the number just the way they are. So watch what I do. I'm going to do this step so you can understand what's going on. I'm going to leave this side the same. I've decided that I want to make this 2 right here a 3. All right, I want it to be a 3. If this number changes from 10 to the second to 10 to the third, then something got to happen to this number because I need the two terms to equal each other. All right, so this is a rule I want you to remember. When this number goes up, this number goes down. So I want you to take that decimal point and move it back one spot. So what you're really doing is going 0.3 times 10 to the third power. What you got to understand is that 3 times 10 to the second is the same as 0.3 times 10 to the third. They mean to say, if you work this out, you get 300. If you work this out, you get 300. They both equal the same thing. All right. But the advantage now is that these two exponents are identical. All right. When these two exponents are identical, watch what we can do. I can actually take this number and put them in the same parentheses. Sorry, that will be adding. All right, let's do that again. All right. And then this term here and that term here, you're going to write one time. And the reason you only write it once is because both of these terms will be multiplied by that one time. Here, they're separated. So this is multiplied by that. That is multiplied by that. But when I write it again, I only need to write it once because both of these numbers are still there inside parentheses. Got it? All right, that's why I only need to write it once, because both numbers will still be multiplied by that term. So watch what I do next. All right, let's go back to our parentheses here and add these two numbers. That'll be 2.3 times 10 to the third. Okay, now this is what you need to know. That's my answer in scientific notation. If I want this to be in standard form, I'm going to keep going and take this decimal and move it 3 places to the right. 1, 2, 3. Add my 2 zeros, and what do I have? 2,300. They match. This term up here and this term down here both say 2,300. All right. Now, if I wanted this one here to be in scientific notation, I would just convert it and go 2.3 times 10 to the third power. Just convert it. All right. All right. Very good. All right. Let's do one more example here. All right. All right. Let's look at something with some subtraction here. So let's go with 9.1 times 10 to the third power. And I want to subtract. Let's go with 1,100. Okay, let's do that. Now, first of all, okay, you can simply work this out and subtract 1,100 and have the answer. All right. So that is one way that you can do it. All right. An easy way that it can be done. Let's do it that way first. I want you to see that even if you see it like this, you can move that decimal 3 places to the right because of that exponent and get 9,100 and subtract 1,100. And the answer is 8,000. And if you convert that to scientific notation, you'd have 8 times 10 to what power? Third power. How did I get the third power? I made sure that I counted my decimal places. 1, 2, 3. My decimal will go there. So therefore, I got to have a 3 in my exponent. That's it. That's my answer. All right. But obviously, that is the easy way, and that works. You can do it that way. But I have to show you the other way, because there are times when the numbers will get so large that you will not be able to just work this side out by itself. All right. So I want to show you the other method. Okay. Just in case you're not comfortable with working out very large numbers. What do I mean by very large numbers? If this number right here was a 30, I would not write a 91 with 28 zeros, 29 zeros. I wouldn't do it. So you got to have another method to avoid writing very large numbers or very small numbers. So what I do is, if the numbers are small enough for me to work it out like this, I work it out like that. If the numbers are too big and I got like 15 or 29 zeros, I'm not doing that method. I'm using this method because I don't have to do any of that with this other method. So watch what I do. You'll be like, okay, I understand. All right, so what I want to do first is change this number right here to scientific notation. I need that to be in scientific notation. All right, so let's rewrite it. 9.1 times 10 to the third minus 1.1 times 10 to the third. All right. 1, 2, 3. Yep, 3 to the third. I had to make sure we was right. All right. Guess what? My exponents already match. Therefore, I can do this. I can put these two numbers in its own parentheses. And then these two numbers will be together. That's already the same. All right. So watch what I do. 9.1 minus 1.1 times 10 to the third. Remember, we only write that once. So I'm showing you here that they already match. Okay. So when we work this out, what is it? 8 times 10 to the third. That's it. There it is. You see it right here already. And what is that number? 8,000. That's it. See it right here already. All right. All right. Very good. Great job.